based on what we did earlier and to find the amplitude and all that.
Yeah.
Correct? So how do you find the amplitude? Suppose you have a function. So how do you find?
You would do max minus min divided by 2.
Correct? So your amplitude is equal to, I'm just writing the formulas again for your reference.
Yeah.
So amplitude, so your model is y is equal to a sine b x minus c plus d.
Yeah.
Or y is equal to a cos b x minus c plus d. So a is your amplitude, which is max minus min divided by 2.
Yeah.
Your d is what? Max plus min divided by 2. You remember that?
I never remember there were no...
See, listen. There was no D.
There was no D.
Oh, D is your horizontal shift.
And there was also no horizontal.
Oh, okay. I'll tell you, there's nothing. It's nothing. See, it's like this. So
Yeah.
this is your max. This is your min.
Yeah.
If you minus it and do it, you'll get the amplitude. If you minus and do it, you'll get the amplitude.
Right, yeah.
Achha, if you take the average, you'll come to know how far it has gone up.
Wait, so you do...
Max y...
Max y plus
minus
minimum
min y upon 2 is your A.
Okay.
Is the amplitude.
So if it's minus 1, you do minus 1.
You take the value. Minus
1. 2, 1.
Minus 1
okay,
you do.
Right. Oh, you do minus 1. That's for this.
That's for
But here...
Yeah, the plus minus 1.
Plus minus 1, yeah. Okay.
Okay. That's your... B is what?
Horizontal stretch.
B is 2 pi divided by the period.
Oh, right, yeah.
And what is the period? Period is, if you have a graph...
How long
period is max to max.
Yeah, max to max.
Or min to min.
Min to min, yeah.
Min to min is the period.
One cycle.
One cycle. Correct? If you have to do in degrees, then 360 divided by degree. Period.
Yeah.
Correct?
Right.
Achha, and what's your C?
C is your horizontal shift. And each point you just subtract.
So if it's a sine graph, you take the horizontal shift of this point.
Just that point?
And if it's a cos graph, you take the horizontal shift of this point.
And
because your parent function of sine starts like this, na? 0 to pi. You need this point. How far, how left or right?
You can just take 3 points.
Yeah, then just take this point and see how much is shifting. Like suppose if this is your sine x, correct?
Yeah.
And suppose if your graph had started here and this was, let's say, pi by 2.
Yeah.
Then this graph would be sine x minus pi by 2.
And then you can just do the same for all the points.
So this is what you need to remember.
Yeah.
But that's it. So now they'll give you in words. So what you need to do is just think what the max and what's the min.
Okay.
Now we start with non-applied problem to review the ideas that were involved. Now in sine cosine wave, the max point is given to you. The max point is given to you, pi by 3, 6, and the next minimum point is given. So they've given you the coordinates of this and this. The max point is pi by 3, 6, and the min point is 5 pi by 6, 2. Like this. We know the max and the next min. Suppose you want to find the equation in the form of the cos. Okay, find the amplitude.
Max minus min, so 6 minus 2.
No, minus 2. Why minus 2? That is 2, no?
Sorry, yeah, minus 2 divided by 2.
That's 4 divided by 2. So that's 2.
Yeah.
What's your K? K is your vertical shift.
Vertical shift, yeah.
So what's your K is your vertical shift in this bond. So this is your vertical stretch. You remember, no? This is your horizontal stretch.
Yeah.
This is your
horizontal translation.
Horizontal translation. This is
vertical
your vertical
translation.
Okay. So vertical shift is your K.
Yeah.
That's 6.
Yeah.
Plus 2 divided by 2.
Right.
Max
6
plus min divided
max
by 2.
Plus min divided by 2. So that's 4.
8 divided by 2. That's 4.
So that means you have y is equal to 2 cos. And b x
minus so y is equal to 2 cos. We have to find out b. Correct. You have to find out h. Correct. Plus k plus 4.
Yeah.
Correct.
Now
this is to be determined.
Yeah. Now you need to use the period.
Now.
So
what is the period?
2 pi.
Now period is what? Now how much of the graph is this? From
That's
here to here?
Max
No, how much of the graph?
It's
Period
not
will come
half
this
a
way.
cycle.
Half a cycle. So to get the period, you'll do this minus this.
Yeah.
Multiply by 2.
Yeah. Because it's half.
Because half the cycle. So period will be 5 pi by 6
see.
minus pi by 3. Correct? Whatever answer you get, you'll multiply that
So
by
that's
2.
3 pi by...
So 3 pi by 6.
Yeah.
Correct? So that will be 2 into 2 pi by 6.
Yeah.
Correct?
Which is...
2 3s are 6. 2 pi by 3
Yeah.
is your period.
Nice. So
And
that's
what's the value of B?
The value of B, that's your period, right?
2 pi divided by period.
2 right. 2
pi divided by 2 pi by 3.
By 3.
So B is 3.
I see.
So that means you got your B as 3.
Then how do you know your horizontal shift?
Correct?
Yeah.
Fine. We'll come to that. If we use a cosine function with positive A value, then what is the shift? I told you, look at the maximum value.
Yeah.
Look
Max?
At this. Look at this.
Huh.
Now where is it starting from?
Yeah.
Pi by 3.
Pi by 3.
In the parent function, where does cos start? In the parent function, 0.
Yeah.
Instead of starting from 0, it is starting from pi by 3.
Yeah.
Correct?
So that means it's shifted pi by 3.
So minus pi by 3.
Ooh, it's not that difficult at all.
Yeah. So use your parts A to C to write the equation in the form y is equal to, we wrote this equation only.
Yeah.
That's your part D. Correct? Check by using graphic calculator to graph the function. Remember to use radian mode, and then you can do that.
Yeah.
That you can do that. You understood how to do this?
Yeah.
Next.
Okay. One morning, the high tide at the Fitzgerald Marine. So it's going to be word problems.
Word problems.
All of these.
But the idea is the same. Max, you have to think of the max and min. Occurred. So see, high tide.
So one
high
is
tide
9.
Is the max.
Yeah. Max is, yeah.
So max
so
is
9.
High tide at 9 a.m.
Yeah.
And
9,
the height is 8.2 feet.
8.25.
8.2 feet, correct?
Yeah, 8.2
The next
feet.
low tide, so this is the high tide. The next low tide
occurs at 3 p.m.
3 p.m. So this is your time.
Yeah. Which is water of...
3 p.m. and 3 p.m. would be 15 hours.
Yeah. Oh, yeah.
In a 24-hour clock, this would be 15 hours because this is 9 as a high tide.
Okay.
And 15
so you have to use your brain a bit.
Yeah. Not a bit, a lot.
A lot.
And this is 0.6.
Yeah. 0.6. Okay.
So low tide is this is 0.6.
Yeah.
This is 8.2.
8.2.
Okay.
So that means now you can find your amplitude.
Fine. Now, if T represents the number of hours after midnight, use the steps from question 1 to write your equation in this form.
So
Same
it's a
steps.
cos function.
Cos function, okay.
Because it's starting from the max.
No, not necessarily.
Okay.
It's a cos function because they've asked you.
Because So what you could do is you can do 8.2.
So A is equal, so what is the A? Let's
Yeah. So your A is equal to 8.2 minus 0.6 divided by 2.
That's how much?
That would be
7.6
divided by 2, which is 3.3.
3.8.
3.8. Sorry.
Correct. Anybody randomly calls. Want to buy a house? K.
So
8.2.
8.2 plus 0.6 divided by 2.
That's how much?
8.8 divided by 2 is 4.4.
That's your K.
Yeah.
So you got this. First you'll always get this.
No.
So that's you're using your Y values.
Yeah.
Now
you need
period.
your B.
Now what's your period?
So that would
first before getting your B you have to get a period.
So that'd be 2 pi.
2 nahi.
So 2 times
This
2 times
15 minus
15
9.
minus 9, yeah. 12.
Correct, 15
Right.
and 6, 6 2s are 12. So period is 12. Therefore, what will your B be?
2 pi upon 12,
Ah,
which you cancel, so it's pi upon 6.
okay. Now, this is your horizontal shift. So this is your horizontal shift, no?
Yeah.
How much is horizontal
9.
shift? 9.
So you would do,
So,
we have the
Y
equation.
is equal to
2,
3.8.
3.8 cos,
pi
T,
by 6
yeah,
T,
T
minus
9
plus 4.4.
Okay, nice.
So A, B, C and just the shift.
Just
the C is
step
just
by
the shift.
step.
Step by
First
step.
find the amplitude,
Yeah.
then find K, then you can find your B period, then
Yeah.
you find the horizontal shift.
Yeah. You have your calculator with you?
I do, yes.
Okay. So do this. Enter this in your
Regression?
regression.
Oh, really nice. Regression.
But you can also, just to see the graph actually.
Yeah.
What you can do, see, I'll tell you, Ruhan. In this case, what you do is you take your joiners 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yeah.
Now what do you see? Look at the max. What's your max temperature?
66.
66 is max. What is the min?
41.
Correct. So if you happen to graph this, at 1 it's 41 and then it's 66. At 8 it is 66.
Yeah.
You know, if you are not doing regression, the first part I don't think so to do regression. So explain why it makes sense to use a sine or cosine function that you'll see in your calculator when you graph it.
Because it's
so
starting,
your points will come like that.
Yeah, it's starting from
when you draw a scatter plot, you will get points.
But that would be a sine graph, right?
It can be sine, cos, anything it can be. It depends on where you start from.
But cos graph always goes from the max.
No,
low,
see, I'll tell you.
right?
Listen. If you have a graph like this now, if you use this as a starting point,
then it's sine.
Then it is minus cos.
Oh, right.
It gets reflected.
Cos.
Acha. Now, if you use this as the starting point, no, then it will be plus cos.
Okay.
If you use this as the starting point, no, then this will be sine.
Because 0, huh?
So it depends. So so when you have a wave like this, you can either fit in a minus cos.
Yeah.
You can fit in a plus cos. You can fit in a plus sine. You can if you take this, it will be minus sine.
I see. Okay, I didn't know that this was minus cos.
So minus cos. So this is your cos. This is your minus cos. This is your sine. Sorry. This is your sine. This is your minus sine.
Yeah.
Correct?
Yeah.
Your cos starts from max. This is your cos.
Yeah. Like quadratic.
And this is your minus cos.
I see. Okay.
So it depends on where you start. So all the points would look the same.
Yeah.
So now this points, when you graph it, you'll get points like this.
Yeah.
So you can fit in cos or sine, it doesn't matter. So you can say experiment makes sense to use a sine or cos function because it resembles either sine or cos function. Correct?
Yeah.
The points.
Right. It depends where you
starting point.
Yeah.
Absolutely.
Okay. So
it's asking you why sine or cos and not a straight line or not a parabola.
Because it's
because it's periodic. You can say because it's periodic.
And it's not linear as well.
No, it's not linear as well. It's not quadratic. It's not cubic.
Not quadratic or cubic.
Because it's going up and down. It's having a definite max, definite maximum, definite minimum. It's having. Okay. Now what will you do?
Regression?
No. Regression will, I think, will come in the end. Find the value of A and of K. Now we are using the same model.
We did A.
So your model is the same. Your teacher is using these variables.
Okay.
Plus K. So your teacher is using this variable.
Yeah.
So what is A?
So our max 66 minus 41 divided by 2.
That's 25. Correct?
Yeah.
Divided by 2. 12.5.
Yeah.
Correct. What's your D?
So D would be 66 plus divided by 2.
2 5s are 10, 2 3s are 6.
Yeah, 0.5, yeah.
Correct?
Yeah.
Show these values, show the equations used to find that we should show. Equations to find these values. What is the expected period of the function that models monthly temperatures?
Expected period of the function that models. So, where does it?
12. No?
12. So 2 pi.
Monthly temperatures will be because every the seasons repeat. No? Like
it would be 2 pi though upon.
No, period. Period will be 12.
Period would be 12.
B would be 2 pi divided by 12.
Right.
So B affects the period. B itself is not the period.
Right.
Like your A itself is the amplitude.
Right.
Your K itself is your vertical shift.
Right. Yeah.
But a period is not B. That you need to remember.
Okay. What is period then? Like shift?
Period is your one cycle.
Stretch.
How long does it take for one cycle?
Right. Okay.
Period is how long it takes for one cycle.
Okay. But you wouldn't put 12 in there.
Now see here, suppose if you say this is 1 and this is 8, correct? So this is how much? 7. So period should be 14.
Period. Yeah. Okay.
Because double of that. But generally if it's seasons or monthly temperatures, it will be 1 year.
Yeah.
Because the periods will repeat. Like every May it will be hot.
Right.
So every May the temperatures are high. So the period would be 12.
Okay.
Like that. So expected period and what the graph gives. So expected period is you logically you think.
Yeah.
Sometimes the data points may not exactly represent what common sense would sometimes say.
Yeah. Okay. That's weird. But
Because in modeling that happens.
yeah.
Modeling is not a textbook question where you will exactly like when you do real life modeling, it will be little off.
But that's fine.
And that's fine.
I see. Okay.
Suppose t is equal to 1 is used to represent Jan, t is equal to 2 is used to represent Feb.
Yeah.
Decide if you want to use a sine function or cosine function to model a graph. Which one would you like to use?
Let's use a sine function.
Cos function is better always.
Okay, cos function.
Because you know the minimum.
Right.
So that you use that as a shift directly.
Right. Okay.
If you want to use a sine function also, I'll tell you what to do. Okay?
Okay.
Then find a phase shift. Phase shift is your H.
H.
H is your phase shift.
Yeah, horizontal.
Yeah.
Horizontal shift.
This is also called a phase shift.
Right.
And write the equation of the function and model the temperature. So what will it be?
So it'd be y is equal to the amplitude was 12.5 cos.
But it will be minus. It's starting from down, no?
Right. Yeah, we are.
So
Yeah,
don't
you're
try.
starting from down. That's why I was saying
Pi by 6.
sine.
No, sine I'll tell you if you do sine. We'll put sine also.
Okay. Pi by
X,
6
x minus 1. It's your horizontal shift.
Right, 1, yeah.
Plus 53.
53.5. That's it.
Now if you want to put in the sine function, you'll have to start from this point. Because then you'll get your sine function.
Yeah,
You'll
right.
get your sine function. So you'll start from, so that means that will be the midpoint of these two.
Right.
So that would be 4.5 because 8 plus 1 divided by 2.
So that would be your horizontal.
So this will be a principal axis.
Yeah.
So at 4.5. So what will it be if you want to do the sine function?
So y is equal to 12.5 sine pi by 6 x minus 4.5 plus 53.5.
Perfect. So either you can put in the sine function or cosine function.
Okay.
Only your starting point would be different.
Okay. I see. This makes sense.
This is the whole idea of your starting point.
Yeah.
If you do this minus cos, sine, cos, minus sine.
Okay. This makes sense. This makes sense.
So it depends on what your initial point is.
Yeah.
According to the model, what is the average monthly temperature in Feb? How does it compare to the actual average? So Feb, if you are doing the average temperature in Feb, so let's take the cosine function. So minus 12.5 cos. For Feb, what will you take your x's? If you want to find a temperature in Feb.
March, June.
2, no?
2, sorry, I don't know where I was looking.
Yeah. X is 2 you'll take.
Yeah.
Pi by
I was
6.
looking for February.
2
but
minus
I
1
couldn't find
plus 53.5.
it. Yeah.
Substitute this and get the answer
So that's.
on your calculator.
What do you mean substitute? Just write the equation like this?
Type it in to get the value, no?
Or calculator, comma x.
Calculator.
And put this equation, comma x. And solve.
Not and solve. Directly type in minus 12.5.
Okay, minus.
It's a radian, na? Minus 12.5.
It has to be in radian?
Yeah. Because minus 12.5. Why are you putting answer?
Why is it coming?
Because you have to take the minus, small minus. Where's the small minus? There's a bracket, there's a small minus also. Okay, ठीक है. Minus 12.5 cos pi by 6.
Another
No,
bracket?
pi by 6 into 1. I mean, directly take pi by 6. Pi, you could have slash 6, you could have put it.
Oh, right. Pi divided
Doesn't
by
matter.
6.
Plus 53.5. Because into this is 1. What's the answer coming to? 42.6?
Yeah.
42.7.
I don't know, you can just directly do that.
Why not? Because all the numbers are there, na?
Right.
So 42.7 is what the model gives you.
Right.
What is the actual observed temperature?
44.
Observed temperature is 44 degree Fahrenheit.
Yeah.
And this is this. So therefore your model will always be different.
You said there can always be some.
So always, the model will not exactly fit.
Right.
It just gives you an idea.
Right. I see. Okay. Very nice.
Choose a different city and look up the average temperature of each month, and then this is like,
More practice. Fun practice.
Practice. But then sign regression, that we'll do tomorrow. Then.
Okay. All right.
Done?
Lovely. Yeah. Also, I have.